Hi, my name is Shahroz Ahmed, and in this video I'm gonna do some physics questions for SABIS Curriculum. So I have some revision sheet in which there are the physics questions, so I'll do some of the questions for you, and let's see how it goes. Alright, so the first question, these are the basic. Okay, so in these ones we'll have the basic questions and the grid questions, as you all guys know who are doing SABIS. So let's start off with the basic questions for the chapter 1, vectors. So it's mechanics 1, and it's come under the umbrella of physics. So let's start off with the vectors. So now question number 1, it says what are the magnitudes of a unit vector and a zero vector? So it's quite straightforward. The magnitude of unit vector is 1 and the magnitude of zero vector is 0. Simple. Now let's move on to question number 2. Question number 2 says given two vectors u and v below, construct the vectors 2u minus v. So 2u minus v. So what we have to do is we have to double the magnitude of u and we have to change the direction of v, and then we will add them by head to tail. So let me just draw 2u. So 2u will look like this. Alright, so let me just draw the u first. So let's suppose this is u. So the 2u will look like this. Same direction but double magnitude. Now negative v. So v is like this. So the negative v will become the same magnitude but the opposite direction. So this will be the vector negative v. So now I'll join these two vectors by the head to tail. So it will look like this. This is 2u, and over here we have negative v. I'll join the tail of negative v on the head of 2u. Now let me just draw the resultant vector. So the resultant vector will be, the tail of the resultant vector will be the tail with the tail of the first vector, and the head of the resultant vector will be with the head of the last vector. So it will be like this. This will be the resultant vector. So this will be my answer, and this will be equal to 2u minus v. Alright, now the next section, it says write the expression for the position vector of point 9, negative 6 meter in both the Cartesian form and in the column notation. Alright, so the Cartesian form, let's start in the Cartesian form. So basically this is the distance that has been traveled by the point M from origin in the horizontal direction, and this is the direction that has been traveled in the vertical direction. So let's suppose we have XY coordinate system. This is the origin. So this point has traveled 9 units to the right and 6 units down. So 6 units down will be somewhere here. Let's suppose it's negative 6 over here. So this point will be right over there. So we have to write down the position vector for this vector. So let's write down in the Cartesian form first of all. So it will be 9i minus 6j, because this is the distance traveled in the horizontal direction, so it will be represented by the unit vector I, and the negative 6 is the distance traveled in the vertical direction, that will be represented by unit vector j. So this is in the Cartesian form. Now let's see in the column notation. So in the column notation it's quite simple. You'll just write 9 and negative 6. So this 9 represents the distance traveled in the horizontal direction, and this number tells us the distance traveled in the vertical direction. Alright, now we have question number 2. It says given p 0 8, q negative 2 1, and pr negative 4i plus 2j. So these are the vectors that have been given to us, and we have to work out 3qr minus 2pr. So in this one we have pr that is already given, but we do not have qr. So in order to find out qr, let's write down these vector p and q into in the Cartesian form. So p means op, so that is equal to 0i plus 8j, and q means it's like oq, that would be equal to negative 2i plus j. Alright, so this is OP and OQ. Now QR will be equal to OQ minus OR. Now from here I have to work out, I do not have OR, so I'll try to work out OR from PR. So PR is equal to negative 4i plus 2j, and as we know that PR is equal to OP minus OR. So from here I'll work out my OR. So OR will become equal to OP minus PR. So OP is 0i plus 8j, and PR is negative 4i plus 2j. So it will become 4i because 0i plus 4i will become 4i, and 8j minus 2j, it will become 6j. So OR is equal to 4i plus 6j. So I'll insert this OR over here, and OQ is already given, that is negative 2i plus j, minus OR is 4i plus 6j. So when I'll solve it, it's like minus 2i minus 4i, it will be like minus 6i, and j minus 6j, that would be equal to minus 5j. So I got QR. Now I'll use this vector QR to work out my expression, that is 3QR minus 2PR. So for that purpose, let me just erase it. I'm going to erase this working, and we'll work out 3QR minus 2PR. So it's 3QR minus PR. So it's like 3 times negative 6i minus 5j, minus PR is negative 4i plus 2j. So it'll become negative 8i negative 15j plus 4i negative 2j. So negative 18i plus 4i, it will become negative 14i, and negative 15j negative 2j, it will become negative 17j. So my expression will become equal to 3QR minus 2PR will become equal to negative 14i negative 17j. So this is how we will do this question number 2. Alright, let's do this question again. So question number 2, it says given P 0, 8, Q negative 2, 1, vector PR is equal to negative 4i plus 2j. Find this expression 3QR minus 2PR. So we have to work out this expression, and we have these vectors. So let me just write down the position vectors first. So it's like OP. So I'll write it over here. OP will be equal to 0i plus 8j. Then we'll have OQ. That will be equal to negative 2i plus j. Then we have PR, and we have to work out this expression. So in this expression we have PR available, but we do not have QR. So in order to work out QR, I'll do it here. So QR is basically equal to OR minus OQ, and we do not have OR, so we'll try to work out OR from this vector PR. So this vector PR is basically equal to OR minus OP. So OR will become equal to PR plus OP. So PR is negative 4i plus 2j, and OP is 0i plus 8j. So I'll just add them up, so it will become negative 4i plus 10j. That would be OR. So I'll insert this value of OR over here. We have OQ already, so we can work out the value of QR. So my QR will become negative 4i plus 10j minus negative 2i plus j. So it will become negative 4i plus 10j plus 2i minus j. So negative 4i plus 2i, that will become equal to negative 2i plus 9j. So this will be my vector QR. Now I'll have QR, I have PR, so I can work out that expression. So let me just erase it. So this expression is 3QR minus 2PR. So 3 times QR, that is negative 2I plus 9J, minus 2PR, so PR is given already, that is negative 4I plus 2J. So it will become negative 6I plus 27J plus 8I plus minus 4J. So my answer will become 2I minus plus 23J. So this will be my answer for the expression 3QR minus 2PR. Alright, so let's do this question. It says express the following as a bearing. So we have been given a direction north 50° east. So we have north at this is the north direction at the top. At the bottom we have the south, at the right we have the east, at the left we have the west. So we have to find out this as the bearing north 50° east. So first of all we will go at the north, and from the north we will move in the clockwise direction towards east. So we will move 50° to the east, so it will be like this. The 50° will somewhere here. So now let's measure the bearing. So the bearing, in order to measure the bearing, will always start off from the north and move in the clockwise direction. So whatever is this direction, the same will be the bearing. So for this one, the bearing will be equal to 50°. So the answer for this one will be a bearing of 50°. Now let's try this one. So the method is quite simple. You just have to go at the south, then you have to move towards west by 32°. So this is south, and now we have to move towards west by 32°. So if we move 32° towards west, that will be somewhere here. So this is 32°. Now we have to measure the bearing. So in order to measure the bearing, we'll start off from the north and we'll move towards this direction. So we'll move in the clockwise direction. This is 90°, another 90°, another 32°. So the bearing will become 90 plus 90 plus 32. That will become equal to 112. So for this one, the bearing will be 112. Sorry, so this one, for this one, the bearing will be 212, because 90 plus 90 plus 32 will be equal to 212. All right, now let's try this one. South 40° east. So we'll stand at south and we will move 40° towards east. So this is south and we have to move 40° towards east, so it will be like this. So I have to move 40° towards east. Now in order to find out the bearing, we have to start off from the positive north, and we'll move in the clockwise direction. So up till here it's 90°, and from here to here that will be equal to 50°, because this is 40, so this total is 90. So 90 minus 40 will be equal to 50. So for this one it will be 90 plus 50, so the total bearing will be equal to 140°. So for this one the bearing will be equal to 140°. Now let's try the next one. So this says north 60° west. So what we do is we'll go at the north, and from the north we'll move 60° towards west. So 60° towards west, it will be somewhere here. From north we will move 60° towards west. Now let's find out the bearing from this figure. So from the north we have to move in the clockwise direction. This is 90°, 180°, 270° plus 30°, because the angle from here to here is 60, so the remaining angle will be equal to 30. So it will be 270 plus 30, that would be equal to 300. So the bearing for option D will be 300°. Now E, it's quite simple, due west. So due west means you have to move here. This is your angle, due west. So the bearing will be 90, 180, 270. So for this one it's simple, 270. Due north due north is in the same direction as of the bearing, so it's like this. So for this one, the bearing will be equal to 0 degrees. So this is how we can find out the direction with the help of bearings, and this is how we can understand the directions. Thank you. Alright, so let's do this question. In this question it says, given vector A and vector B, find A dot B and the angle between A and B. So we have to find out the dot product of vector A and B. So for the dot product, I write it as A dot B equals to 2i minus 7j dot 5i minus 4j. And this one, this 2 will be multiplied with 5, so it will become 10. I times I is 1 and I times j will be 0. So we will not multiply 2i with negative 4j, because I times j will become equal to 0. So there's no meaning of multiplying 2 with negative 4j. So 2i times 5i, it will become 10, and for this one, negative 7j times negative 4j, it will become plus 28. So A dot B will become equal to 38. Alright, so this is the dot product of A and B. Now we have to find out the angle between A and B. So in order to find out the angle, we have to use this formula that says A dot B is equal to the magnitude of A times the magnitude of B times cos of theta. So from here I'll say that cos of theta is equal to A dot B divided by the magnitude of A times the magnitude of B. So the magnitude of A, in order to find out the magnitude of A, it will become square root 2 square, that is 4, plus negative 7 square, that is 49. So it will become under root 53. Now let's find out the magnitude of the vector B. That will be equal to 5 square, that is 25, plus negative 4 square, that is 16. So 25 plus 16, that will become equal to 41. So it will become under root 41. So I'll just insert these magnitudes over here, and I already have A dot B. So A dot B is 38 divided by under root 53 times under root 41. So from here I'll get the value of cos inverse. That will be equal to 0.815. So this is equal to cos of theta. I got the value of cos of theta. Now theta is equal to cos inverse 0.815. So I'll do cos inverse 0.815. So my answer will be equal to 35.4 degrees. So the angle will be equal to 35.4 degrees. That's the answer. I hope you got it. Alright, so let's do another question. So this question says, find the vector equation of the line that passes through the point M, whose vector is given by 3i plus 4j and is parallel to v equals to I minus 2j. So remember, whenever you have to write down the equation, so that equation will be like this: A equals to A plus B t. Alright, so in this one it says the vector is parallel to this one. So this vector will be considered as the gradient. So now this B will be equal to this vector, and the position will be considered as the y-intercept. So I'll say that this vector will be equal to A. So my A will become equal to 3i plus 4j, and my B will be equal to I minus 2j. So my Y will become equal to 3i plus 4j plus B is I minus 2j times t. Now I'll just expand the brackets and separate the vectors, the unit vector I and j. So it'll be like this: 3i plus 4j plus ti minus 2tj. So my final vector will become equal to 3 plus t, that will be like 3 plus ti, and for this one it will be like 4 minus 2t. So I'll write it as like this: 4 minus 2t times j. So this will be my final vector. So I hope you got it. So this is it. Thank you so much.